In the last video lecture, I have talked about the Paxos mechanism for the permission blockchain. Today we have a RAFT mechanism, and this RAFT mechanism is the mechanism which is use the Paxos mechanism's experience. Basically, if in the Paxos mechanism, if more than one proposer propose the value and a kind of same conflict may arise, like suppose the proposer value have not notified the final message to acceptor, and before that the another proposal come by someone else, then in those situations a kind of algorithm cannot stop that one, that the next proposer. So in that situation, a kind of a leader consensus is used for that. So this very basic idea of leader selection is adopted in the RAFT mechanism, and it is the simplified mechanism in comparison to the Paxos. So as I said, that this RAFT consensus is designed as an alternative to the Paxos, and the generic way to distribute a state machine among set of servers ensures that every server agrees upon same series of state transitions. And the basic idea is to the nodes collectively select a leader and the other will become the followers. So as I said, the RAFT mechanism use the majority of the vote will be received by that node. That node will be the leader node, and other will follow that node. And all the log maintenance in the transactions to storing in the log will be given by the leader only, and the responsibility will be of the leader. The leader is responsible for state transition, log replication across the followers. So this leader selection will be for particular term. So time to time, next leader will be selected. So re-electing a leader, committing multiple values to the transaction log, and dealing with the replica failure. So this is the basic task of the leader. So there may be more than one candidate for the leader position. Other will be the follower, and leader will be that node that who will receive the votes from the majority of the servers. So candidate can wait for a timeout, and he may participate in the new election. Candidate may request to the followers for the vote. So these are the three states we have here: a leader, candidate, and followers. A leader, after finishing of the tenure, after finishing of the term, he may again request for the leader. Now, the voting request, whatever the value of the term value will be, it will be incremented by 1, and it will be the next term value which can be used by a particular leader candidate. The second, the vote for request by any leader candidate have two values. The first one, the next term value, that is the last calculated plus 1. And the second one, the index, This index is nothing but the committed transaction available to all the candidates. So this candidate, whatever the committed transaction he have, this value will be the second field of the request vote. And this request vote will be sent by this leader candidate to all other nodes to get majority. Follower will receive the node's request and he will decide according to this mechanism. He will check whether this term is less than the term value known to the node. If it is less than, then it will be declined because it is obsolete one. Next, he will again check the index value. Index value is the last committed transaction. So if this index is less than the known value of the committed transaction to this node, then again it will be declined. And if is it not so, then this node will vote for this candidate. So each node compares received term and index with the corresponding current known values. Now, use of majority voting. This majority voting is used for the leader selection and committing the transaction on the log. So this node will be the leader if he will receive majority voting, and from the leader candidate the state will be the leader, and if is it not so, then this node will be the follower. Now see this, take this example. Suppose a multiple leader candidates we have in the system. Then current multiple leader candidate, and the condition is suppose current leader failures. So suppose this is the situation we have, the term value is 10 and the known index is 100. And this is the leader, and this leader have 3 followers. And suppose this leader got failure. This node is failed. Then definitely this 3 follower will try to find out the next leader. Suppose this leader, this follower propose a value, it will increment to 1, then 10 to it becomes 11. And this 11 message is sent to all the remaining node in the network. And suppose he received the message and he becomes the leader. Now this new leader has been elected with the term 11. And then suppose this old leader recovered, then he will be simply follower. So old leader will receive the message from the new leader with the greater term. Then this leader will change his state and this old leader will become the follower. Now, suppose 2 nodes sends the request vote message with the next term. Suppose this is the another scenario. There are 4 nodes here, and 3 node is the follower node and 2 are the leader candidate. So you can see this node shown in the green color incremented 1 and sends the vote message to all follower node with term value 21, and this also send with the term 21 to all follower node. So one of them will be the leader. Suppose this received 2 votes from these 2 follower and this leader candidate received just 1. So this will be the leader. And after winning, getting the majority vote, he will send the message to all the nodes about the winning this leadership candidature, and this node, the leader candidate, will change his state and he will become the follower. Now for the committing entry log also, leader will send the message to all the follower, and with the next log, suppose current index is 100, then next log index will be 101. And for committing the transaction on the log, he will again take the majority voting. As I said previously, this for leadership selection and for the entry log, the majority voting is used. So leader will send the append entries with the new transaction number to all the follower, and again the majority voting mechanism is used. Successfully accept the entry log, all leader and follower will update to this 101. Handling failure up to n/2 - 1 nodes doesn't affect the system due to the majority voting. But if the Byzantine behavior occurs, then this algorithm, both Paxos and RAFT, are not able to handle the situation. And the Byzantine, the both Paxos and RAFT cannot tolerate up to n/2 - 1 number of crash node. And this is the Byzantine behavior, that someone give different values to different receiver, that this one sends to this to attack, and the retreat message to this one. So this is known as a malicious behavior, and we consider this type of behavior of a node as a Byzantine fault. And both Paxos and RAFT are not able to deal with this type of behavior. So for that, we have another algorithm, that is a Byzantine fault tolerance algorithm, that is BFT, and its improvised version is a practical Byzantine fault tolerance, that is PBFT. So we will discuss this both algorithm in the next video lecture. So enough for today. Thank you.